Yeah, good afternoon. 1 hour to briefly mention about this topic on chemical perspective on analysis data scientific. So I'm going to share my screen. ID, can you use your phone? Thank you. Yeah. Can you all see my...
No, Doktor.
Boleh?
Tak nampak.
Yes, video. So if I go... Okay. Nampaklah kan? Yeah, okay. For chemical perspective, it was more to very wide because I did some chemical analysis using regression, like looking what are the relationship between parameters, looking at what are the effects of certain elements towards one parameter. So most of the time for chemical perspective, I've been using regression and some of the studies variety along, I mean there are a lot of variety of chemical perspective on data analysis. So I was trying to summarize everything, and then I was like, I don't want to miss something because it is quite wide, like biology where you have all the indexes and then there are different kinds of tests in it. And then I was looking at chemistry, it was like, alamak, full of questions for me to answer in a very long term run. But then comes back to this class is that we are looking at some basics, so that from the basics, then when you go into higher level, then we will go into that. But basically, I'm still sticking to what Dr. Chong's have taught you in the early semester of all kinds of statistics, and then I'm going through some case study of what people have done. So the question here actually goes back to the video that I share in the WhatsApp group for everyone. But before I go into that, I'm going to show you like one or two case study why I am a little bit concerned on academics and science. Okay, we go through this, all right? So one case study is that the use of water quality index. So I always compare with biology because my background is still biology. So there are a lot of indices that record. So water quality has index, and to determine the index, they must have a few parameters, and there must be an equation how to calculate the water quality index. So in this paper by Didi, not Dr. Adiana, is this Zulung Tung Didi, I don't know how to pronounce his name, on this water quality explore half paper that published in 2013. It's the same thing, either it's a sea or it's a lake, but still a water quality index. So it studied at this Turkey area. And what happened for this case study is that if you look into this first box, it mentioned that in this study, we utilize different water quality indexing. Means that they are going to look into different kind of index generated by different people at different time. For example, the Shannon index, Simpson index, Magalev index. So it was created by different people at different time. So water quality index also have a lot. And then the purpose of this paper is to investigate the differences of quality index by these 5. So they have CWQI, OWQI, ATP, OIP, and UWQI. So they uses the same parameters or different parameters that determined by this index, And from these 5, they see what are the differences, right? So that is the... So the question here is like to investigate the I'm supposed to draw, right? Okay. So to investigate this thing very okay. To investigate using this. So they want to know the differences. This is the aim of this paper. So as I read the paper and then I was trying to figure out, and then the last one is that they summarize the results of all applied water quality from the rank of the WQI values from 0 to 100. Okay, so they rank each, the 5 ones. And then at the end, they said, based on the discussion, the result presented above conclude that CWQI, this one, let me get another color. CWQI and OWQI, okay, display realistic result in compared to raw data. Okay, so they compare to raw data that actually the data that were actually from the equation itself. So the raw data was BOD, phosphate, E. coli, and then all these. Okay, and then exceeding. So at the end is that in these 2 parameters can be easily is the lowest index value. Okay, so you can see that they just conclude that actually without any statistical analysis, it was just based on the value. And if you look at these 2 value, it was all like less than 60, or it was like here, you know, it was very less than the ATP, OIP, and then all the other parameters. You can see these 3 have always high number. You see, it's all at higher ranking. But then the other 2 was at lower. And then they just conclude that these two index is the most suitable one. But the whole paper, there was no statistical analysis. There was no comparison. Are they significant or non-significant? So this is the lack of this publication. So I'm reviewing the publication and showing you how weak a publication can be. And then let's go to the next one. Case 2, that one was at Turkey. Okay, let's go to case 2 where we want to look at comparison between water quality index and biological water quality index. Okay, there are 2. One is on physical, the water quality normal WQI, and the second one is the BWQI. So this is closer to us. This is at Melana River, Johor. Okay, so the paper mentioned that the main objective of water quality modeling is to describe and predict the observed effects of the changes in environment. So if you look at the objective, you will know that they just want to know the changes of the river system water quality before, and then they want to model out next one, right? So when you have an objective, so the conclusion of this paper is that Melana River can be categorized as polluted class 3 because WQI in the classification of the numbering 56 is class 3. It's a polluted area. Okay, based on the assessment of water quality index and BWQI. And then the level of pollution in this river was found affected by its surrounding. From observation, you can see here, this is observation. This is not by experiment. This is not by, what's the other method? It can be a survey, it can be a model out, observation and experiment. Observation, experiment, another one is what? Siapa boleh tolong jawab lah? Let me get to the chat room. Nobody can help me to answer. There are 4 types of getting data. One is you do collection by survey. One is that you observe, sit and observe. One is experimental, means you have to do experimental on it, and the other one is what is it? I pun lupa. Lama tak buat nota. Okay. So it's just that we have to do analysis. You go back and cari lah. So this paper mentioned that the observations said that it contributes the water pollution from industry, commercial, and resident activities. But what are the percentage? If I am the reviewer, I'll be looking at what are the percentage of effects, because to determine something, to determine a river condition, polluted, non-polluted, is just one data that don't really being like in science, like we have to find the cause. It's not just to say, okay, class MSDA is all first class. I can conclude that by giving your results. But the question here in science is that always like, why? Why does it happen and how does it happen? So this paper actually does not answer the objective. And then on the other hand, biological also say consists of survey of direct measurement for aquatic life. Okay. And then they only found that microbenthos live in water that are suitable for their survival. So if you look at the conclusion and you go back to the objective, when you go back to the objective is to describe and predict the observation effects of a change in river ecosystem. Actually, the paper have not described the change of the river system because there doesn't have samples before and after the influence of either industrial, resident, or commercial buildings. So they didn't do. So most of the time when I do review of other fields, because I am in biology field, so in marine science itself is a very large field. So when it comes to teaching this geological and chemistry field, I did not use any journals from lecturers within UMT because I don't want to review what other people are doing. So if you remember the video that I sent to you all in WhatsApp group, did you all know what is the funny thing of that video? Bukalah video. Today I just want to chat first. Stop sharing my screen. Anyone can literally tell me like how funny is it when you look at the video? What do you think on science and education? I think I should send that into the group. wonder you all didn't watch what I get. If one person discover it is not science enough until many scientists agree it is. That's what I think, Doctor. What do you think about science and publication? So Anissa gave us things that we can ponder. That is what she think is that if everyone agrees, then it is science enough. So to get everyone agree, it is not that easy because, for example, for the past 50 years, there are many people in the earth still say the earth is a flat. There are people in the group saying that it's a flat earth, means our earth is not round, it's not a globe. So there are still this kind of people, and many of them believe that the earth is still flat, and it can change with time, I guess. So Sanka said, you think it will change through time. So actually, statistic is the killer for most scientists, especially in Malaysia scientists, including myself. It can be modified. Actually, information and characters of science, like it can be by many research that can be modified to be better, because every time there are weaknesses in certain aspects. So for example, the first two case study that I gave, so we know the weaknesses of their paper, right? But in science perspective, I am an academics. So actually the video actually targeted like an arrow shoot to me, like to an academics. Because for academicians, we have to teach students, right? I have to teach you of what is data scientific in chemistry. But then at the same time, I also have to do my own research. I also have to publish papers. And when I publish paper, only these few 5-10 years, publication is getting harder and harder. It is because one thing that need to be to publish is that the paper must be submitted to someone to review. So when someone to review, for example, if my project, right, I have to review, for example, your FIP next year. So somebody have to review your research project. So if your research is on geology and then your thesis, your FIP was sent to me as a biologist, at the end I have a lot of questions. For example, the questions that I gave in geology last week is that how do geology scientists determine the differences of A and B? They don't use statistic studies because different locality of geology is really different. So there's nothing to prove by spatial or temporal. And then Nur Izzah say we are able to predict something with scientific theory. You predict, but must be proven. So I just want to say that from the video, actually it hints every one of us is that either you as a student, me as a lecturer, is that everything that you read on using science paper, like the one that I shared, a case study, sometimes they are reviewed by friends. So for example, Maldin sent his paper to me because I am his mentee. So I like, okay lah, boleh lah. And then like, this one change a bit, reports, for example. Then after that, okay, Maldin said, okay, I lulus, I can submit because he is my mentee, right? And then others who are not my mentee, then I said, Allah, why you do this wrong? Why you do that wrong? So everyone have there must be bias of everyone. Like we try not to bias for every student. I won't give extra marks for Maldin. for his assignment in this class anyway. Is according to the rubrics. But then there is always like, when you want to talk to a lecturer, of course, out of 78 of you, there must be one or two lecturers that you totally love and you totally like, and you would want to talk to them, approach to them, whatever they say, oh yeah, yeah, betul, betul. But some lecturers that you don't like, or maybe myself that you don't like, whatever I say, alamak, tak betul. There is always emotions in knowledge, okay? But knowledge doesn't change. It's the emotion that change. I think I dah better banyak. Okay. Let's share back this one. So the next case study, I hope that looking at case study, you would know that there is differences of every journal that you read. And if you have enough knowledge, you can critically see what are the disadvantages or the loopholes in the article itself. So for example, this case study, this is using uranium mining waste to look at the toxicity level to fish embryo. Okay, so in this study, they use fish embryo acute toxicity test, the FET test, to determine the reproduction and the life cycle of this fish using water from the pit, treated water and sludge. Okay, so if you look through this paper, is that there are different ponds from this uranium power plant, and all this water cannot be discharged. So one example that is very hot in debate in Japan is that all the water that were collected in Fukushima power plant, they used to collect the rainwater that goes into the power plant. They collect into drums of water so that the polluted water would not seep into the sea. So last 2 months, Japan decided, because they don't have enough space to store the water, they are going to release the water into the environment. And then this caused a lot of debates to countries using the sea. The same thing happened to this journal, is that they want to look at what kind of water conditions that can be released back into the environment, looking at the acute toxicity test to the fish larvae. So if the fish cannot survive the water, of course the water is not safe to be put back into the environment. Okay, so you can see the water that were maintained on a normal fish water maintenance. This is the condition, this is the water quality conditions. But from the other 4 water that they have collected from 1, 2, 3, 4, okay, there is for the deposition, the ponds here and the mines. So there are few parameters of water. So they collect the water and you can see directly that it is different. So you can see that the water condition is different from the normal. The pH is lower, the pH is higher, okay? And then what happened is that statistically, it is trying to prove. So if you look at this journal, it is a very good concept where it is just a histogram, okay, a bar chart showing us the mortality, okay, the hatch egg, the date, the yellow one, and the red one is malformed fish. So they do a comparison of all the control of different environment, different concentration, okay, different concentration of water, and they prove that that is significantly different by putting a mark of a star here. So you can see the date, okay, the date, for example, this figure of ESS, the percentage of embryo of the date in this concentration 84 is significantly different from other concentration and control. So we know now that this, even though the value is low, but it's significantly proven. So it means that if we put the concentration of fish into this concentration, the ESS, into 84, 82%, then it will cause significant death to the fish. Okay, so these can be presented, the statistical tools that you use can be presented in figures, or it can be presented in text. So for example, this text of genotoxicity, it was clearly written here that intermediate concentration, the p-value is less than 0.01. Using t-test, it was 0.004, means it is 95% support that there are differences. Okay. So it can be put in like this figure, or you can put it into like this. So not necessarily the test have to be proven, and I always want to tell students, especially when you are going to your FYP, please do not put this type of analysis back into your report in your final year project or your report, because a lot of the time data can be analyzed using Excel. So in Excel, this is the kind of output that would be given in a time, for example, ANOVA. If you do an ANOVA of multi-parameters, what are the relationship? And then you run the data, comes out in Excel, this is how it looks like. And most of the time, students would copy this and put the whole table into the reports, which is wrong, because this is a guideline for you to tell us DF is the number of samples. The p-value should be put either in text like before, or in figure that you want to present. But there is nothing that you want to present, or nothing that you can tell from this MS and SS. So there is no point of you putting this table back into the report. Okay. Got me from here? Sudah setengah jam malam. Okay. And then as I go along and prepare the notes, one thing that I learned, I think this is a good analysis, but this analysis was seldom used for biological, seldom used for geological on selecting our sampling site, because sampling sites are determined by the objective. But if there is, or there are someone who are going to do experimental, means you want to, for example, the temperature effects to fish. So you want to test what kind of temperature that affects the fish growth. The question here is that when you want to do experiment, the first question is that how many samples in that tank of fish that you want to put. You cannot just put 3 fish. If all the 3 fish dead, and you can just say, oh, all the fish dead, they are significantly cannot survive in that temperature. Cannot. Okay. There must be a statistical tool to decide what kind of sample size. So if you, if any of you are going into this field, into experimental and doing designs, especially in tanks and aquariums, make sure that you go and explore more on this sample power analysis. So this sample power analysis actually provides you a number of how many samples do you need to collect and experiment on, so that your statistical test letter is enough and normal. So that, for example, if you look at these 2 studies, the treatment and the control. So if I have 30 samples, 20 plus 25, 20, maybe 50 samples. Then when after I got the data, it shows differences. But it can be because my 30 samples is not enough to represent. So I need to do 50. So when you have 50, it comes up to have different analysis. N samples is very important in any analysis. If your N is only 2, nothing that you can do. If your N is 3, you would have one line, it doesn't prove anything. Okay, Dr. Chung always emphasize that, especially when you're looking at regression, cannot have 3 points in that graph. And actually, in most of the scientific studies, when we ask students, so they say 30. 30 is the minimum. 30 not necessarily the minimum. It depends on your parameters. What are you measuring on each of the N sample analysis? So a lot of factors. So the question here goes back to the recap of what we have learned so far is that when you define the research problem and research question, it actually links to your data collection. Okay, if you want to know the differences of food to the students of MSDA, this class, we must make sure that all the students participate. It cannot be only female students participate, or maybe those KL students participate, cannot. So the definitions of variables and measurements must be equally representative for all the students of MSDA. So if I'm going to do an analysis, I did ask you all to if you want to do analysis of your weight changes before puasa and after raya, right? So if everyone willingly contribute to the data, then we have 78. Maybe including myself and Dr. Chung, then we have 80 samples. But out of that, maybe the boys are interested, so they do the collection of data and then do analysis. It doesn't represent all the students of MSDA because the ladies don't join, because they are shy. They increase their weight after raya. Okay, so at the end is that we want to communicate the results. Okay, let's look at case study number 3. Look at the storm and then the runoff quality of pollutant waters. And you can see that this study aims 3 objectives: to characterize, to establish the relationship, and to predict the equation to estimate the uses. So from these 3, so they actually have box plot. I think for the past 1-2 years, I likely like to do box plot because box plot actually give us a very good descriptive idea of the data distribution. So for example, in these studies is that, for example, this figure, we can easily know in this condition of residence, the RES, the residential, the wet and the dry, the wet here and the dry here is different. Okay, but then statistically is look into the text. Okay, let's go to the next slide. Is that they do statistic analysis by looking at the p-value. Okay, so all the data, just now as I mentioned, do not put in table if you are doing single parameters like ANOVA in a single table. But this table is conclude of all the parameters, the residential, the commercial, and the industrial. So they have 3 components here, and each of the parameters have each indicator of the BOD, TSS, the total suspended solid. Okay, so what they do is that they look at the R square, what is the relationship of these two, and then is it significant or not? That comes to the next slide where I want to quickly tell you that when do data analysis on regression, a lot of the time people would ask, what is your R square? Or what is your R? So when I look into R, people would say, okay, my R, for example, this is 1. 1 means whatever happens to Y is the same that happens to X. So if Y is plus 1, X is plus 1. That is called one relationship of X and Y. So if this is the figure, it is called negative. So this is called -1. So most of the time is that when we do a lot of analysis, people would say, let's find the R value. the R value, right? So if this is the R value, the R value of this equals to 1. And then this R value equals to -1. So R is between 1 to -1, right? And then, of course, there are times where you have no correlation, where you have non-linear regression. This is when you go further in, there are multiple regression by when you have two. Let me, how come my arrow always go missing? Ayah, okay. Whatever is it, when you have two, then it become binomial. Okay, when you have more than two curves, then you have nominal polynomial regressions. So regressions is just the gist of telling you what are the differences of x and y. So if your r's equal to 1, it's actually given you a result if it is significant. Yeah. I hate when my, okay. So when you look at this is all analysis that you can do with linear regressions according to what is it. So you can see here, this is positive 1, 0 0.8, 0 0.45, and this is how you calculate. And this calculation, you can just go to Excel, or you can use R software right now that I think you can already download, and you can write command, what is the test, what is the R. So the R gives you a lot of evidence of the relationship between X and Y. So when you have two relationship, it is so that you want to test. If the relationship is 0.1, it is a weak relationship, but it doesn't mean that it cannot be significant. Okay, so to test the significance, we still have to do statistical tests. Okay, either one tail or two tail, left tail or right tail. So last week, I think last 2 weeks, we were talking with Dr. Chung. Rupa-rupanya, I did explain wrongly in geological. So the tail is at looking at the tail. The tail is on the left, then it's skewed to the left. If the tail is on the right, then it's skewed to the right, right? So we want to look at the R and R squared. Okay. So if you look at here, the definition of R linear regression is what are the data to the line regression line that we are looking at. So if you look at these two data sets, this is more significant, and you think that this is better because it is nearer to the line and all the data gave a very good concentration in between. But over here, you can see all the data are scattered, but we still can draw the line. If I don't draw the line, you might think it is no relationship, where it was no correlation like this. So if you look at this weak positive correlation, it's because you can see there is a line there. Okay, you can estimate the lines by putting to the computer what is the regression line. Okay, so when we have the regression line, you know it's positive or negative. So let's go to one of the projects that we did. I mean, I am more comfortable of explaining my own research field, but you can imagine this as, for example, parameters of time towards water quality, because parameter can change from biology to chemistry. It's just that you replace the value of it. Okay, so for example, this is my data from biology, but you can imagine that if this is like BOD level, this is salinity, this is temperature, it's still the same. We want to look at the differences of this parameter on the y towards the x. X is time. So the time that we did the analysis was between 19 1980 to the year 2010. So it's a 30 years record. So you can see that this is negative. The R here is negative, negative, negative. This is negative. This is negative. This one is don't know. Okay, this can be positive or negative because it doesn't show. But then you can see here that this is all negative. Okay. This is all negative. And you can see that using statistical tool, we can know that this 3 dot means it is 99% significant. But if you look at the data set, it is not really towards the line. The data still scatter very far from the line. But we have hundreds of data to represent. And when the calculation did the analysis, it mentions that it is significantly reduced throughout time. So you have 2 star where it's 95%, and then we have the 1 star 90%. Okay, so this is the relationship. So for example, this bulk density, or maybe I can change it to CO2 level in 1980 to year 2000. You can see the changes is very little. Means every year the CO2 level reduced just little by little. It is a weak regression, but it is very significant. Means if there is the time keep on going, I can significantly tell you that the CO2 level is getting lower and lower. Okay. The next question here, next slide is that a quick test for you all. Okay. My question is that which of the following, the A, B, C, D, E, F, give us negative trend? Somebody can put into chat room. Which of the 6 figures show us a negative trend? A, yes. Lagi. B, yes. A, B, C, F, yes. C, A, B, C, F, C. Okay. Most of you answer C, 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 F. Okay. So if you look at the trend, it's actually this noted. Go back. A and C. So when I ask trend, trend is the relationship of the Y and the X, the regression is that this one. So if you say analysis trend negative, 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 and negative. Okay, so most of you answer correctly part of it, but when I ask what is the negative, which one negative, so now we know that A, B, C, D, and F is negative. Only, okay, only this one is positive. Okay, so using your naked eye, which one do you think is significant? This is the tricky one. Which one is significant? Which one do you think is significant? Okay, Atira answer C, C. Anissa F, C, F, 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 F. E. A. Okay, so from all the answers, some of you answer F. Let's put another color. Some of you answer F. Some of you answer C, and then some of you answer A. Okay, if you look at this data, if you look back into my journal, actually those significant is actually the answer will be A, B, and F. Okay, F is very simple that you can see all the data set is within the range. So of course you would think that it is very significant. Okay, and then B and A and B you do not think is significant because there are so many data outside. Okay, and then the gray bar value is very high. And then C you think is very significant because the gray line is very small and then all the data is quite nearby to the line. And then of course, you have the right one, nobody choose D and E because both is not significant and you can see the data is scattered. Okay, so actually for our objective, we just want to look at the trend. For 30 years, one line. But after this paper that was published in 2013, we have another paper came out in 2016. Then we tried to look at 5 years point because we found out that, for example, this you can see if you look at the data, actually it's not linear relationship. It was actually polynomial relationship. If you look at it closely, the data have different time because at different time zone from 1990s here, the conditions favor for the coral to grow larger. So sometimes linear is not everything. Linear is just one relationship directly influenced by one parameter. But if you look into biological or even chemistry, it can be have different shape. Okay, so all this must be done. Okay, it can be used Pearson test, or you can use a t-test, you can use a f-test. This is all the tests to look at the significant level. Okay, one more case study from my journal. This was recently published last year. I think this one I've told somebody on this case study, but I don't remember which class because I'm teaching 3 courses. So if I repeat, then yeah, you just take into it. So we want to look at the coral skeletal luminescence. So luminescence are caused by terrestrial chloromorphic dissolved organic matter, DOM. We call them the CDOM because it's a chloromorphic dissolved organic matter in the coral skeleton. So it is more to geology and chemistry based. So the chemistry is this component, the DOM itself. So what happened that in our research, we using the samples, the geological samples, that we trace back what are the CDOM throughout time in the sample itself. And then if you can see here, I just want to tell you that you can see here our R square is only 0.5. So if it's 0.5, R square is usually between 1 to -1, right? So 0.5 is considered weak. Okay, it's considered weak. But our studies actually showed that this is significant from the RMSE, means it doesn't change a lot, and it was written in the text, the p-value was 0.05. Okay, so you can see that sometimes do not use one parameter to explain your data. Okay, you cannot have just if the R is equals to R square is equals to 0.02, it doesn't mean that nothing to tell. But your 0.02 means your R, your Y value is only 2% related to the X value. Okay, that is interpretation. But for your level, I think linear regression is good enough for time being, because most of the time is to determine what are the differences of one parameters towards another parameters. But in the real life of science, ding, 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 if you have stop, okay, if if in science linear regression is very normal, and at the end is that a lot of the time, especially in chemical perspective, it is no longer linear, because for example in this journal, DO2, the maximum there, the nitrogen, the sulfate, the temperature, all the parameters actually give an input to a certain aspect of your study components or the locality that you are looking at. And all these parameters actually give a significant input. And this is what we call multi-regression analysis. But do not be afraid. We are not going to teach you on this multi-regression analysis, because you should be concentrate on your linear regression first. Okay. I think that's all from me today. It's almost 1 hour. It's almost time up. Stop sharing screen. So you can, hopefully by the case study that I gave you from biology, from geology, from chemistry, you would know that different kind of fields have different analysis and different approach to the objective. And I just want to emphasize here, especially when you want to read journals and read books, read it with the knowledge that you have, that you do critical thinking on it, because not every journals that you read, uh, how to say, it is all information is correct. It is just that the information can be fully analyzed, or it can be half analyzed, or it's just a data to present, or nothing to prove. It is just a data presentation. So for example, for biology, most of the time we present data rather than asking the question why. So statistics actually helps uh, anybody in the management or in science or in community. Statistic is the answer of your why. WHYY, not y axis y, it's WHYY. So if you have question why, then we have to use statistical to answer that why does it happen and how does it happen. Okay, so I'm going to see you again on Thursday, because this is something that everybody have to agree on, that after discussion of myself and Dr. Chong, because this whole semester you should have 4 tutorials and 1 assignment, correct? And until now, you only actually do 1 component of tutorial on the biology, and I have not fully give you the tutorial on chemistry, geology, and Dr. Chung next week on physicals. So we have actually, we discuss and we think, because of this COVID and because of stress, our stress and yours, to reduce your stress, we decided to include the assignment into your tutorial. So supposedly 10% for tutorial 1, tutorial 2, tutorial 3, tutorial 4, and 10% for your assignment. So the assignment, we are going to divide that into your tutorials. So we have to maintain the 4 tutorials, because you still have to understand the biology, geology, physical, and chemistry components. So we are going to up the tutorials to 12.5%. As our tutorial actually assign and ask you what are the test suitability that is similar to the assignment. So we don't want to give you extra assignments at the end of the semester. We are going to do these 4 tutorials. Ada bantahan tak? If somebody bantah, then we have to do assignment. Okay. Okay, thank you very much for your support. So this week, I'm going to finish up the tutorial on physical and chemistry. Physical is next week. I'm going to finish up the tutorial of geology and chemistry. And I'm pretty sure these two tutorials are shorter than biology, because biology, I put a lot of effort in asking a lot of questions. You orang pun dah takut. So I'm going to quickly this week, this Thursday, I'm going to give you these other two tutorials on geology and also on chemistry. Okay? Boleh?
Boleh.
All right.
Uh,
Okay, that's all for me today. Thank you very much. See you on Thursday.
Thank you, Doctor.
Thank you.
Thank you, Doctor. See you later.